Most Toyota owners accept the way their car sounds because they believe changing it requires a $600 catback exhaust system, a professional exhaust shop, and hours of labor. That belief is wrong. There is one overlooked component buried underneath every Toyota that controls more of the exhaust tone than most drivers realize. It is not the muffler. It is not the catalytic converter. It is a part called the exhaust resonator, and swapping it for an aftermarket unit costing around $30 changes the entire character of how a Toyota sounds. Not louder, not ricier, deeper and smoother, and closer to the refined exhaust tone Lexus engineers spend millions perfecting. I tested it. I measured it with a calibrated decibel meter, and the results were not what anyone expected. Before explaining the M-mode, you need to understand why your Toyota sounds the way it does, and why a Lexus using the exact same engine sounds completely different. This is where most people get confused. Toyota and Lexus share engine families across their lineups. The 2GR V6 engine that powers the Camry V6 is closely related to the unit found in the Lexus ES350 and the Lexus RX350. The 2.5-liter dynamic force four-cylinder that sits in the Camry, the RAV4, and the Corolla is the same base architecture used in the Lexus NX and the Lexus ES250. Same displacement, same cylinder head design, same valve timing systems, same block casting. Yet a Lexus always sounds more composed, more refined, and more premium than its Toyota counterpart. That difference does not come from the engine. It comes from the exhaust system. Toyota engineers designed the exhaust system on vehicles like the Camry, the RAV4, and the Corolla with one goal in mind: suppression. They want the cabin to be as quiet as possible because silence sells in the commuter car market. To achieve that, Toyota uses oversized mufflers, heavily restrictive resonators, and multiple sound-deadening chambers that kill almost every interesting frequency the engine produces. The result is a car that sounds muted, flat, and lifeless from the outside, and nearly inaudible from the inside. That approach works for comfort, but it strips the engine of any character. Meanwhile, Lexus takes a completely different approach to exhaust tuning. When Koji Sato led development of the Lexus LC, he wanted a sound that inherited the DNA of the legendary Lexus LFA. That LFA program was obsessive about exhaust tone, so much so that Toyota's longtime exhaust supplier Sango modeled the sound profile after human vocal patterns using techniques borrowed from phonetics. They analyzed how sound frequencies interact the same way linguists study vowel pronunciation. The LFA's triple-exit exhaust system was designed to amplify high-frequency harmonics above 3,000 RPM, while filtering out undesirable low-frequency noise. The intake system was tuned by Yamaha, using rigid walls and ribs inspired by musical instrument construction. That level of obsessive sound engineering cost hundreds of millions of dollars and a decade of development. Obviously, you are not going to replicate the sound of a $400,000 supercar on a Camry. But the core principle behind what makes a Lexus exhaust sound premium is transferable, and it starts with understanding what the resonator actually does. The exhaust resonator is a cylindrical component welded into the exhaust pipe between the catalytic converter and the rear muffler. On most Toyotas, it sits roughly in the center of the vehicle under the passenger compartment. Its job is to cancel specific sound frequencies before exhaust gases reach the muffler. Think of it as a pre-filter for noise. The stock Toyota resonator is designed to eliminate almost everything: low tones, mid tones, and anything resembling a growl. It is intentionally oversized and heavily chambered to make the car as quiet as mechanically possible. The problem is that this level of suppression also removes the pleasant frequencies. It kills the deep, smooth bass note that gives a luxury car its signature sound. That is why your Camry with a 301 horsepower V6 sounds like a sewing machine, while a Lexus ES 350 with essentially the same engine sounds composed and refined. The fix is not a resonator delete. That is the mistake most people make. Removing the resonator entirely opens the exhaust system to uncontrolled sound. And on a 4-cylinder or V6 Toyota, the result is harsh, raspy, and genuinely unpleasant. Forum after forum confirms the same result. Owners who delete the resonator on a Camry or Corolla report a high-pitched buzzing tone at cruising speed that causes headaches on long drives. That interior drone comes from specific frequencies the resonator was originally designed to cancel. Without anything in its place, those frequencies bounce freely through the cabin floor and firewall. The drone becomes so persistent that many owners end up welding the stock resonator back in within weeks. The correct approach is a resonator swap. Instead of deleting the resonator, you replace the oversized stock unit with a compact, straight-through performance resonator that allows the deeper frequencies to pass while still filtering out the harsh buzzing tones. This is exactly what Lexus engineers do at a much higher budget level. They tune the exhaust path to emphasize the frequencies that sound smooth and powerful while canceling the ones that sound cheap and irritating. A well-designed aftermarket resonator replicates that principle at a fraction of the cost. The part I tested is a universal stainless steel straight-through resonator with a perforated core wrapped in sound-absorbing fiberglass packing. These are widely available from brands like Vibrant Performance, Total Flow, and several no-name manufacturers on Amazon for between $25 and $40. The specific unit I used measures 2¼ inches inlet and outlet diameter, which matches the factory exhaust pipe diameter on most 4-cylinder Camrys, Corollas, and RAV4s. V6 models typically use a 2½ inch pipe, so you need to match the diameter to your specific vehicle. This is critical. An undersized resonator creates a restriction point that robs low-end torque and causes turbulence noise. An oversized resonator creates gaps where exhaust gases expand and contract unpredictably, producing a hollow metallic tone that sounds worse than stock. If you made it this far, consider liking this video, giving it a thumbs up, and subscribe to my channel. Subscribing helps me bring you more honest car advice. The installation requires cutting out the stock resonator and welding or clamping the new unit in its place. A local exhaust shop will do this for $40 to $80 in labor, depending on your area. If you want reversibility, ask the shop to use exhaust band clamps instead of permanent welds. Band clamps create a gas-tight seal and allow you to swap back to the stock resonator anytime without cutting. This matters if you lease your Toyota or plan to sell it in factory condition. The total investment for the resonator and the install sits between $65 and $120 depending on how you approach it, with the part itself rarely exceeding $35. Compare that to a Borla or MagnaFlow catback system that starts at $450 and can exceed $900 with installation. I measured the stock exhaust at idle from 20 inches behind the tailpipe using a calibrated sound level meter set to a weighted measurement, the standard weighting curve used for automotive exhaust testing. The stock Camry 4-cylinder registered 58 decibels at idle. After the resonator swap with the engine warmed to operating temperature, the same measurement point showed 63 decibels at idle. That is a 5 decibel increase, which sounds modest on paper, but represents a noticeable real-world difference because the decibel scale is logarithmic. Every 3 decibel increase represents a doubling of sound energy reaching the ear. At 2,500 revolutions per minute in neutral, the stock exhaust measured 71 decibels and the swapped resonator measured 78 decibels. That 7 decibel jump makes the exhaust sound more than twice as loud to the human ear, but the tone itself is what changed most dramatically. The stock exhaust produced a thin, buzzy tone with almost no bass content. After the swap, the tone shifted to a deeper, smoother note with a noticeable low-frequency presence that is much closer to what you hear from a Lexus ES at the same engine speed range. At highway cruising speed, where drone becomes a deal breaker, interior cabin noise measured 67 decibels stock and 69 decibels after the swap. That 2 decibel difference is barely perceptible inside the car. There is no drone, there is no buzzing, there is no vibration through the steering wheel or floor pan. The straight-through resonator design prevents drone because the perforated core and fiberglass packing absorb the specific mid-range frequencies, typically between 80 and 250 Hz, that cause resonance inside a closed cabin. This is the fundamental difference between a resonator swap and a resonator delete. The delete removes all frequency control and lets everything through. The swap replaces restrictive frequency control with selective frequency control. You keep the smooth, pleasant tones and eliminate the harsh ones. There are a few critical details that determine whether this mod sounds refined or terrible. First, the position of the replacement resonator matters. The new unit must sit in the same location as the factory resonator, roughly in the center of the vehicle, between the catalytic converter and the rear muffler. Moving it too close to the catalytic converter amplifies high-frequency exhaust pulses before they have time to smooth out in the pipe. Moving it too close to the muffler reduces its effectiveness because the sound waves have already established their pattern by that point. The factory mounting position exists for a reason. Toyota engineers placed the resonator there because that is where sound wave cancellation is most effective for the pipe length and engine firing order of that specific vehicle. Second, the internal design of the replacement resonator is everything. Avoid cheap units with no packing material inside. A hollow tube with holes punched in it does almost nothing to shape the sound. The best results come from resonators with a perforated stainless steel core surrounded by high-temperature fiberglass or basalt wool packing. The packing absorbs high-frequency harshness while allowing low-frequency bass tones to pass through the perforated core freely. This is the same principle used in premium catback exhaust systems from companies like Borla and Magnaflow, applied to a single component instead of the entire system. Third, make sure the exhaust hanger bracket is transferred or recreated during installation. The stock resonator has a welded hanger that supports the center section of the exhaust system. Without proper support, the exhaust pipe will sag, contact the undercarriage, and create a metallic rattle that sounds like a loose heat shield. A good exhaust shop will weld or clamp a replacement hanger bracket to the new resonator to maintain proper exhaust alignment. This detail is often overlooked in do-it-yourself installations and results in owners blaming the mod for noises that are actually caused by poor mounting. The reason this mod works so well on Toyotas specifically comes back to how conservatively the stock exhaust is designed. Toyota over-engineers the sound suppression on its mainstream vehicles. The stock resonator on a Camry is physically enormous compared to what is actually needed to control the exhaust tone. It removes far more sound energy than necessary, which is why the car sounds so lifeless. By replacing that oversized, overdampened unit with a properly sized straight-through resonator, you are not making the exhaust louder in an obnoxious way. You are allowing the engine to express the natural frequencies that Toyota engineers deliberately silenced. Those natural frequencies are the same ones that Lexus engineers carefully preserve and refine at the luxury level. The irony is that Toyota already built the foundation for a great-sounding exhaust. They just muted it. One final point that matters for long-term reliability. A resonator swap does not affect engine performance, fuel economy, or emissions compliance. The resonator sits downstream of the catalytic converter and oxygen sensors, which means the engine control unit receives no data from the resonator and makes no adjustments based on its presence or absence. Back pressure changes from swapping to a straight-through design are negligible because the muffler, which creates the majority of exhaust back pressure, remains completely stock. This mod will not trigger a check engine light. It will not affect your state emissions inspection. It will not void your Toyota factory warranty because it does not alter any powertrain component. The Magnuson-Moss Warranty Act protects consumers from blanket warranty denials based on aftermarket parts, unless the dealer can prove the specific part caused the failure. A downstream resonator swap does not meet that burden under any reasonable interpretation. For $30 in parts and an hour at an exhaust shop, you get a Toyota that sounds like it belongs in the Lexus lineup. Not louder, not cheaper, just better. The same engineering principles that Lexus uses to make a $90,000 car sound refined can be applied to your Camry, Corolla, or RAV4 for less than the cost of a tank of gas. The only difference is that Lexus charges you for the badge. If you're enjoying this video, consider watching this one where I'm sharing more secrets that make your Toyota perform like a luxury car without the luxury price tag.